Okay, so now I would like to make a, sort of a general analysis and find potentially all the Nash equilibrium of this game, the second price auction. So how should I start this? Well, my ultimate purpose is basically to draw the best response functions or correspondence for each player and then see the point of intersections, because I know that if I draw the best response function or correspondence for each player, when these functions or correspondences intersect, well, those points are Nash equilibria, all right? And I don't really have to verify it because, well, that's the definition of Nash equilibrium. Each player is best responding his opponent, remember? So how can I draw the best response function or correspondence in this game? Well, let's start with player 1 first, all right? So I'm going to look at this problem from player 1's perspective. So his opponent bid B2, right? Good. Well, if I bid B1 less than B2, I know that I'm going to lose, and so my payoff will be 0. Okay. Well, however, if I bid B1 higher than B2, what is B2? I don't know at this point, okay? Because remember, I take B2 as given and trying to find a function of, which is a function of B2. So therefore, I don't fix B2. I don't know the value of B2 at this point. So given B2, if I bid as player 1 higher than B2, well then I'm going to win the auction, and by winning the auction my payoff will be my valuation minus the losing bid, which is B2. All right? Well, by the way, you may ask, what if they are equal? Well, for auctions, normally the equalities are not so important, but let's look at it later, okay? I mean, what if the bids are exactly the same? So here, what matters is whether overbidding my opponent is more profitable than not overbidding him or not. So how do I know that? Well, I mean, it basically depends whether V minus B2 is greater than 0 or not. So that basically says the following. If my opponent's bid is less than my valuation V, well, I should overbid him, all right? And if it is higher, meaning B2 is greater than V, all right, in this case, this is going to be negative. V minus B2 will be negative. And so in this case, I shouldn't be overbid him. Okay? Well, is this enough to give me best response? Well, yeah. Why? Well, because here, if my opponent's bid is less than my valuation, I should overbid him. But how much should I overbid him? I mean, if my opponent is bidding B2, all right, should I overbid him like at 1 cent, $1? I mean, how much? It doesn't matter because my payoff is going to be independent of my bid. So therefore, any B1, as long as B1 is greater than B2, is going to give me this payoff, meaning any B1 greater than B2 is in fact a best response. All right, again, this is because my payoff function is independent of B1 once I win. And similarly, once I lose, my bid B1 is irrelevant for my payoff. My payoff will be 0. So therefore, any B1 less than B2 is going to be best response. All right? So therefore, we're not going to be drawing a function, but in fact, we're going to be drawing a correspondence. So here's what it will look like. So I'm going to put player 1's bid. This is the strategy of player 1 on the horizontal axis, bid 2 on the vertical axis. Remember, all the comparisons we have are whether B1 is greater than B2, less than B2. So that means B1 equals B2 is kind of critical point, threshold. So what is B1 equal B2? Well, in this space, B1 equals B2 is nothing but this 45-degree line. All right, so this is B1 equals B2. So this region is where B2 is greater than B1, right? And this region is where B1 is greater than B2. Okay? So once again, how did I come up with this 45-degree line? Well, once again, it all boils down whether meaning the best response, is boiling down whether B1 is going to be greater than B2 or less than B2. So therefore, B1 equals B2 should be the threshold. And so I draw this line. Probably it's going to help me to draw the best response correspondences. Okay. So B2 is less than V. Remember, that was the region where I should overbid my opponent. So let's put V here. W is probably somewhere here. I don't know exactly where because the question doesn't give me numbers. It's just V and W, and V is greater than W. All right, so I just let them appear somewhere here. So if, well, maybe I should put V a little bit closer to W because you know, beyond V, I will also put some marks. So here, this is where B2 is equal to V2. Below V, so whenever my opponent's bid is less than V, the best response, remember, I am going to win if I overbid my opponent. So I should bid more than my opponent. So that's my best response. Meaning, if, for example, my opponent's bid is this level, so this B1 is exactly how much, this B1 is exactly equal to B2, all right? And to be honest, as long as I go to the right, I am bidding, meaning B1 is getting bigger than B2. So therefore, in order not to confuse you with lots of points and drawing, so all these points are best response. Right? It continues forever. However, B2 can be anywhere less than V. So you know what? If B2 is somewhere here, all those points are best response. So that means this entire region, depending obviously on B2, right, are our best response for player 1. Okay? Well, if opponent, player 2 I mean, bids V exactly, what is his best response? Well, again, overbidding his opponent is going to give him, so B2 is equal to V. So he's going to get 0 utility. If he overbids, he's going to get 0 utility. If he underbids, he's going to get 0 utility. So you know what? All of those points are best response. So given that B2 is equal to V, any B1 is a best response. I mean, whether you win or lose, doesn't matter, you're going to get 0 anyhow. All right? So this is exactly how player 1's best response correspondence look like. Whenever B2 is, again, as I said, less than or equal to V. But what about this region, meaning B2 is greater than V? Well, in this case, remember, this is going to be negative. All right, so whenever V is less than B2, this guy is going to be negative, which means overbidding my opponent is going to give me negative payoff. Underbidding my opponent is going to give me 0 payoff. So therefore, my best response is just underbid him, meaning bid something less than. I mean, winning the object is no good under these circumstances. So what does that mean? How can I draw the region where B1 is less than B2? Once again, if my opponent is bidding this much, well, what are the bids that are less than this level? So don't forget, so this is B1 equals B2 line. Everything to the right means B1 is greater than B2. Everything to the left means B1 is less than B2. So this time the best responses are going to be this region. All those horizontal lines are kind of indicating, given B2, what are the best responses, okay? But obviously there are infinitely many B2s. And so, I mean, these are all whole regions. So don't forget that. So these are basically, this is my the player 1's best response correspondence. Okay, given B2, as you see, a lot of strategies are best response for player 1. Well, symmetrically, now I can look at player 2. The same thing, right? If B1 is the opponent's bid, if B2 is greater than, well, let's start with less than B1, I'm going to lose as player 2, and my payoff will be 0. However, if B2 is greater than B1, I'm going to win. And when I win, what's going to be my payoff? My valuation. But don't forget, this time the valuation is W. Okay? It's not V. So U2 is going to be W minus the losing bit, which is B1. Well, the question is, does it worth it? Meaning W minus B1 really greater than 0? Well, it is whenever B1 is less than W. So remember when I was drawing the first player's best response, V was the critical point. Now W is the critical point for B1. So B1 is on the horizontal axis. And so if this is V, remember this is 45-degree line. So this is V. So this is W. So whenever B1 is less than W, okay, player 2 wants to overbid his opponent. And what does overbidding means? Overbidding means B2 must be greater than B1. Remember, this is the region. So therefore, maybe I should use a different color. So for any B1 less than W, B2 greater than B1, our best response. What if my opponent's bid exactly equal to W? The W equals B1. So if W equals B1, whether I overbid or underbid are going to give me exactly 0 payoff. So therefore, all those points are best response. You see, I already have lots of intersection here, meaning I have like infinitely many Nash equilibrium in this region. Later, I'm going to sort of summarize them mathematically. Obviously, there's no Nash equilibrium in this region, no Nash equilibrium in this region. But we're not done yet. I also need to look at the environment where W is less than B1, all right? Meaning to the right of W. In this case, I know that this guy is going to be negative, and so underbidding is the best response, meaning B2 should be less than B1. So therefore, given that V is greater than, B1 is greater than and W, well, what we are going to have is that the bid is going to be less than. So given that B1 is greater than W, B2 is going to be less than. So here is the region. All right, B1, B2 is less than B1. So this is all the region. I should keep continue because as long as, all right, so this blue region is also Nash equilibrium. All right, so that's it. I draw the best response correspondence for each player. The points of intersections are here. Let me use some other color. So I have, a bunch of points, Nash equilibrium points here. And I also have lots of Nash equilibrium points in this region. All right, so in this region, when I said this region, basically to the right of this blue line and below to this black line and also below to the 45-degree line, okay? And this region is basically to the above the V straight line and to the left of blue line. Right? So now let's mathematically, I'm not going to characterize the entire set, but let's mathematically talk about what those sets look like. And let's pick some Nash equilibrium in these regions. For example, where is this VW located? Remember that was a Nash equilibrium V verified. So this is bid of player 1. So player 1 is bidding V, so it's basically on this line. I don't know if you can see it. And player 2 is bidding W. So it's basically this. So VW is this point. So this is one of the Nash equilibrium where player 1 wins. Okay? In fact, I can say all those Nash equilibria are the ones where player 1 wins because they satisfy the following, right? Player 1's bid, as you see, is greater than W. Player's 2 bid is less than V. All right? And what else? All those points are below B1 equals B2 line, which means B1 is greater than B2. So how many such points do we have? Well, infinitely many, as you see, and all of them basically are Nash equilibrium. Okay? Well, what about this point? Again, this point corresponds all those, this characterization, mathematical characterization, basically corresponds all the points here. Well, what about these points? Well, what do they look like? As I said, B2 is greater than V or equal, and B1 is less than W or equal. And then, well, as you see, obviously, because V is greater than W, right? B2 is greater than B1. So what does that mean? That means these are all the points, all the Nash equilibrium points where, as you see, player 2 wins. All right? All Nash equilibrium where player 2 wins. And here, this is all Nash equilibrium where player 1 wins. Okay? Well, if you like, I mean, this is a perfect exercise. If you're not fully sure about your best response correspondences, well, then you can just verify. All right? I mean, this is a perfect time to make a guess. Is this really a Nash equilibrium? I mean, take some point. If you like, give numbers, okay? I mean, I don't know. Say V is equal to 10, W is equal to 5. Really doesn't matter. And B2 is equal to, I don't know, for example, 10, and B1 is equal to, 3. Well, is this really a Nash equilibrium? B1, comma B2, which is equal to 310. Well, in this case, player 1 is going to lose, player 2 is going to win, and because he's winning, he's going to pay this the losing bid, which is 3. So his payoff is W minus bid 2. His W is 5. His bid is equal to 3, and so his payoff is 2. Question is, can they get something better than this? Let's look at player 1. He's getting 0. Can he win the object? Well, he can. How come? Well, because player 2 is bidding 10, he should bid more than 10. But does it worth it? Well, if he bids more than 10, well, he is going to pay $10 because this is his opponent's bid. And so his valuation, 10, minus bid that he must pay 10, is going to give him 0 utility, which does not improve his payoff. So therefore, bidding B1 equals 3 is the best response for him. All right? And if you do the same thing, player 2, he is winning. Very good. Well, the thing is, can he improve his payoff? Well, his valuation is fixed, which is 5. The bid he's paying doesn't depend on his bid. So you know what? The payoff 2 is the best he can get, so he can't improve his payoff either. So what does that mean? That means, for example, this is a Nash equilibrium. Well, what is special about 3, 5, 10, 10? Nothing. As long as B1, B2, V and W satisfy this inequality, they all must be Nash equilibrium. Okay? So I think that part also answers the question, is there any Nash equilibrium where player 2 wins? Yes, there are many of them. But again, in a question like this, so this is a sort of full, compact solution, because you find all Nash equilibrium of this game. But there's always easier. If the question is not asking you to find all Nash equilibria, well, then just make a guess. So in the first case, we just made the guess VW, all right? In the second question, meaning is there any Nash equilibrium where player 2 wins? Well, just reverse things. I mean, I don't know, right? I mean, to me, it is kind of, the obvious kind of candidate, and then verify it. If it is not Nash equilibrium, well, you can make guessing, all right? The thing is, as you guess and see that your guess is not Nash equilibrium, probably you're going to see how players would like to deviate, because, you know, if it is not Nash, that means players are not best responding, so they're going to regret playing that. And so when you see that the players are not best responding, you will also see towards which direction they would like to deviate, like overbidding, underbidding. So after making 2-3 guesses, wrong guesses, you will probably start making more educated guess. All right? But sometimes, guess and verify method is not, efficient. Instead, you should do some sort of complete analysis by drawing the best responses.